Okay, last time we discussed about we stopped at the how we can find the probability value if you are dealing with X random variable that follow normal probability distribution. Okay, and as I mentioned earlier, there will be two ways on how we can find the probability if we are dealing with random variable that follow normal probability distribution. Okay, the first one that we have discussed is if given the probability is in the what we call in the middle of your um, probability distribution. Okay, so this is the first type of your probability distribution, and the other one would be the upper tail probabilities, which refers to the tail of your probability distribution, as what you see from this particular slide. Okay, and before I can go to the second way on how we can find the probability values, if it's involving your the upper tail of the distribution. So we will see the last exercise that I did not cover in our class last time. Okay, so a quick discussion. Okay, find the probability of z is between -1 and 1, z is between -2 and 2, and z is between -3 and 3. And how do these values compare with the empirical rules? Okay, so as we know, okay, we are using the first probability concept. Okay, and we know when we are dealing with z, originally we are talking about x that follows normal with mean, mu, and variance sigma squared. Okay, since we do not want to have so many normal probability distribution table, so we standardize this into what we call standard normal. Okay, when we say standard normal, then the random variables that we talked about earlier on, that is x, will be z, and this z is distributed still with normal probability distribution, but with the mean and variance 0 and 1. Okay, so by applying this concept with the transformation of using the z score, okay, so we have this particular understanding. Okay, now how are we going to find n1? Okay, so we know that if we are referring to the first one, so we have the meaning is 0, z is equal to 0, and the area that we are talking about is between -1 and 1. So we are talking about this region. Okay, if you look at your table of standard normal distribution, so we know that along at this x-axis is referring to the z value. Okay, so we are looking for the z value of -1 and 1. So since we are talking about, since the probability value is given for this particular region, so any discussion on this particular region in green is the same as when we discuss in the red box, because we are talking about symmetric distribution. So if we are talking about the area between 0 and 1, so we are talking about this area. So the value of your probability will be, okay, for z is equal to 1.00, so we are looking for this particular value. Then we know that this is 0.3413, and we know this one also 0.3413. So we know that the total probability will be what? Okay, so P Z between -1 until 1 would be 0.6826. Right. Okay. Number 2, if we are talking about between -2 until 2, we are talking about bigger, what we call probability region. Okay, so we look at our Z 2.00. So this will be the value, and the probability would be 0.4772 multiplied by 2. You will get what class? What would you get there? So you will get 0.9544. And if we are talking about the third one between 3 and -3, even bigger, okay? So we are talking about 0.4987. So the total area of the shaded one will be 0.99974. So if we reflect this with the what we call empirical what we call that empirical rule, okay? So we are talking about this one, and exactly the probability that we are talking about just now, such as this one standard deviation, this one 2 standard deviation, and this one 3 standard deviation. So this will be 68.26%. This would be 95.44%, and this would be 99.74%. And if we look at the empirical rules, so we have what we have just discussed. Okay, so that's how we relate the probability under the shaded area with the empirical rule. Okay, now what if we have this one supposed to be before this one, but I mistakenly put the figure. Okay, so let us look at how we can find the probability value if it involves the area at the upper tail. Okay, so the way we look at our table of standard normal table, it would be a bit different. When we talk about the first table, okay, we are talking about the Z value, which is along the x-axis. These are all the Z values. And the Z values that we will refer to will be at the first column and the first row. Okay, and we know if we are talking about this one, Z is equal to 0. Let's say we are talking about here. Okay, this one would be Z equal to, this is for Z equal to 1.03. Okay, and the probability is given by 0.3485. So when we are talking about this Z value, it is along the x-axis. When we are talking about the probability value, this probability value refers to this particular shaded area. Okay, unlike the first table, because sometimes you may want to find the probability, what if the probability that you are looking for is at the lowest point or at the uppermost point? Okay, for example, as this one. Okay, what if it is the probability that the value that we are looking for is at this side or maybe at this side? So how are we going to solve that? Then it is where you have to use what we call the upper tail probabilities. Okay, now what will be the difference between the first and the second? Now if you can see clearly in the shaded green box, okay, so the alpha here is referring to the probability values. Okay, so what probability value that I'm talking about? So this is your alpha, the shaded area. Okay, probability value that we are talking about is, let's say, 0.071. This one and this one. So this will be the value of your Z. of what? Z of your alpha, which is your alpha is 0.071. Okay, now this is your Z value and this is your alpha value. Okay, your alpha value is your probability value. Now, how are we going to, what kind of situation where we need to use this particular upper tail probabilities? Okay, for example, determine Z alpha such that the given probability of Z greater than Z alpha is 0.25. Okay, in this case, if I were to jot down in terms of your upper tail distribution, okay, we know that we are talking about standard normal, so Z is equal to 0, the mean is 0. So we are talking about Z alpha, okay? Your Z alpha is here, where your Z alpha is given by 0.25. The probability value is 0.25. So what will be your Z value for this particular probability value? Okay, so look for alpha 0.25, 0. So your Z will be 0.646745. 6745. Okay, so that's why your Z alpha, the that we are looking for is the Z value along at the x-axis. Last time we are talking about this probability value. Now, given the probability value, what will be your Z alpha? So this is how we do it. Now, for the second probability, now look carefully at the sign. The sign will give you the hint for the area that you are looking for. Okay, so the second one would be Z less than Z alpha. Okay, so now if let's say I sketch this way 0, and let's say I'm talking about Z alpha here, and it says less than, so means that it will be less than your Z alpha here. Now look at the probability value. 0.36 means that 0.36 is somewhere over here. I put it into your in terms of green. So 0.36 is here. Is it logical? Now give yourself a question. Is it logical? Is it 0.36 should be in the shaded area, or should I put it this way? Okay, so if let's say I'm talking Z alpha is illogical, so in this case wrong. What if my Z alpha is here? Okay, and we are talking about Z alpha less than, the area that we are looking for is this one, and it should be 0.26, and it makes sense, and this one which should be correct. Then only go for the value of your alpha, and then you know that your Z alpha is 0.3585, so it will be 0.3585. And since we know that it is less than 0, we know that the Z alpha will be negative value. So this is how we use the upper tail probabilities. Okay. Sometimes, okay, there will be times where it seems like you will have to use your first table of standard normal. Okay. But if you look carefully, it will be referring to the second concept. For example, find the Z value such that the area under the curve between 0 and Z is 0.2123. Okay, if I were to put that in terms of sketch, so I'm talking about 0 until find the value such that the area, so we are talking about the area here, okay, which is given by 0.2123. So since we are looking for Z alpha here, okay, of course we need to be based on the alpha that we have here. So in order to find this, so it would be 0.5. Why 0.5? Because half of the probability is 0.5 minus 0.2123. Okay, so you will get 0.288 as your what we call alpha value. Then having said your alpha is 0.288, refer to your table of your second upper tail. So that will be 0.288 and you will find your Z alpha is equal to 0.5592. Okay, so that's how we deal with the upper tail probability, upper tail that involve the normal probability distribution. Now, let us look at one example. Very quick because I need to finish the continuous probability distribution. Okay, now, if Z is the standard normal random variable, find the value of Z for each of the following. Okay, I do appreciate if anyone got any problem or any question, so please stop me because since time is very limited, so I'm going to straight away finish up all the materials that I have planned to finish for today's class. Okay, so exercise 2.7, so you can look at your textbook on page 62. Okay, now if the standard normal, if Z is the standard normal random variable, find the value of Z for each of the following. Okay, so the first one, the area to the left of Z. I would like to sketch because it would be easier for me to illustrate the area that the question asks. If you feel that without sketching the normal probability distribution is okay, as long as you understand. Okay, so since Z is equal to 0, the average is at the middle. So the area to the left of Z is 0.9750. So if we are talking about, let's say, your Z alpha somewhere here to the left, so it will be somewhere, the area is somewhere here. Okay, and this is given by 0.9750. So how I am going to find, so of course by using the whole probability value, 1 minus 0.9750, so you will get alpha here is 0.025. Okay, by looking at the alpha 0.025, refer to your upper tail distribution 0.025. Okay, so you will get here Z alpha is 1.96. Number 2, the area between 0 and Z is, okay, so the area between 0 means that from the average value, Z is equal to 0, and Z is 0.4750. So let's say this one is 0.4750. Okay, so of course to find this alpha, so alpha would be 0.5 minus 0.4750. So it will be given by 0.025 as well. Okay, so Z alpha that we are talking about is 0.025, again is 1.96. Okay, and the third one, the area to the right of Z. The area to the right of Z, so Z equal to 0 here. So since it is very small to the right, of course it will be somewhere at the right upper tail. So Z alpha here. So alpha is given by 0.133. Okay, so look for 0.133. 133 is this one. So Z alpha is 1.112. Okay, so that would be for the first question. For the second question, if Z is the standard normal random variable, find the value of Z for each of the following. The area to the left. Okay, so if we are talking about the area to the left, is it the same question? The same question. I coincidentally copy paste the question. How many questions do we have? Okay, now the second question is not this one. Okay, the second question is find two Z values so that 48% of the middle area of the Z curve is bounded by them. Okay, so please look at your, sorry, this one is correct. Okay, so we are talking about the area between two values. So we know that Z is equal to 0 at the middle. So we have Z alpha here. We have Z alpha here. And the shaded area is given by 48%, or we can say 0.48. Okay. And of course, here it will be negative value. Okay. So since we have 0.48, we know that for this portion, it will be what? So this one will be 0.5 minus 0.24. So it is given by what? 0.48, 0.5, 0.4. So it will be 0.26. So if this is 0.26, so this will be alpha is given by 0.26 here. Okay, so look for 0.26. 0.2 is not here. So if you refer to your second table of the upper tail, so you will find that Z alpha is given by 0.643, and this will be negative 0.643. Okay, so that's how we deal with the second equation. Now, all what we have discussed before related to the continuous probability distribution are all the concepts that you need to understand before you can tackle the actual problem related to the normal probability distribution. Now, look at the first example, which involves the actual what we call problem for normal probability distribution. Now, suppose, for example, example 2.18 on page 62. Suppose X is a normal distribution given by mean 25, okay, and the variance is 25. Okay, now find Px is greater than or equal to 24 or less than or equal to 35. So this is where we need to understand how we what we call transform our actual problem to what we call standard normal that is following Z. Z normally distributed with mean 0 and variance 1. Okay, so we are going to start with this particular application now. Okay, so how do we start with the what we call calculation with respect to the actual problem? So first thing first is you will have to transform into Z. Now the equation will be given in terms of X. Okay, so how do we solve? So this will be P24 less than greater than or equal to or less than or equal to 35. So we will need to transform to Z standard normal. So this will be 24 minus the mean here. Okay, minus 25 divided by the standard deviation. So standard deviation is given by 25, square root of 25. And once you have what we call apply the transformation, then X becomes standard normal, so it becomes Z. Okay, the same goes to 35 minus 25 divided by square root of 25. Okay, so solve for this, so you will get negative 0.2, and then you will have 2. Okay, usually if during not during the MCO, this will be given mark, 1 mark method. This will be 1 mark for answer. Okay, but we haven't finished answering these questions. Okay, now since we know that we are talking about the area between the two values, okay, so 0 at the middle, negative 0.2 somewhere here until 2 somewhere here. So if I were to what we call write down the original probability distribution, okay, the mean is 25. So you are talking about the probability between 24 until 35. So this is the difference between normal probability distribution and standard normal probability distribution. If we were to use the normal probability distribution, you are going to need various what we call normal probability distribution. But if we approximate them into standard normal probability distribution with mean 0 and variance 1, so everything would be easier. So that's why it will be this way. Now, let us continue. Okay, so we are looking for this area. So in this case, I use my first table of standard normal. So we are talking about the probability between Z0 until 0.2 plus Z between 0 until 2. Okay, so if you look at your what we call your table table. So if you look at your table, so 0.0793. So please look at your table. So this will be 0.4772. So you will get 0.5565. So this will be the answer for the first one. So the probability for x greater than or equal to 24 and less than or equal to 55 is 55.65. Okay, what about the second? So Px greater than or equal to 20. So this will be Pz greater than or equal to 20 minus 25 divided by square root of 25. So you will get Pz greater than or equal to, if you calculate that, you will get negative 1. So the area that we are talking about is from 0 greater than negative 1. So the whole thing here, we know that this is 0.5. So what about this one? So we are talking about Pz greater than or equal to 0 plus, which is this one, plus this one. It will be probability of Z between 0 until 1. So you will get 0.5 plus, this case, this will be 0.3413. So you will get 0.8413. Okay, so that's how we solve example 2.18. Now, what about example 2.19? Okay, example 2.19. Okay, Malaysian consume an average of 1.64 cups of coffee per day. Assume the variable is approximately normal distributed with standard deviation of 24 cups. Okay, so in this case, we are going to do the few fundamental things before we can answer. So in this case, x will be what? Okay, x, the number of cup of coffee. Okay, and x is distributed following normal with the mean of 1.64 and standard deviation So here given is standard deviation. So 0.24. Since here should be the variance, so you will put 0.24 squared because we are talking about the variance here. Okay. Now, if 500 individuals are selected approximately, how many will drink less than 1? So we are looking for probability of X less than 1. 2 cups. So in my, I am following my previous version, so it will be 2. So less than 2. Okay. So if it is less than 2, okay, then we will follow the transformation for standard normal. So it becomes Z less than 2 minus 1.64 divided by 0.24. Okay. So you will get here it will be PZ less than negative 1.95. Okay. And if we were to look at the area, so 0, 1.95, negative, so somewhere over here, it is the same as talking about 1.95, which is the area here. Okay, this would be PZ, this will be PZ, since we are looking for greater than, since from your first table, it will be this area that is given in your table. So you will have to use PZ greater than 0 minus PZ from 0 until 1.95. Okay. Now, in this case, it would be 0.5 minus, if you look at your table for 0 until 1.95, you will get 0.4744. Okay, so you will get 0.026256, the probability value. Okay, now how if 500 individuals are selected, approximately how many will drink? So how many will drink? You will have to multiply the probability with the number of individuals. So therefore 500 multiplied with 0.0256, you will get 12.8. Okay, or you can approximate to 13. So in this case, 13 people, okay, will drink less than 2 cups of coffee per day. Okay, so how likely this event will occur? Since the probability is very small, okay, so you can say it is less likely, okay, it is less likely that less than 2 people will drink, sorry, not 2 people, less than, it's what, 500. It is approximately, it is less likely that, not 2 people, we are talking about cups. Okay, it is less likely that, what would be the event? The event is, it is less likely that, how would I say? If 500 individuals, it is less likely that, if I go to be specific, it is less likely that 13 people will drink less than 2 cups of coffee per day. Okay, so that will be example 2.19. Okay, so for Example 2.20. Okay. An assessment test is used to measure a person's readiness for college. The mathematics score in the test are scaled to have a normal distribution with mean 500 and standard deviation of 100. Okay. Now, for the second example, it will involve the upper-tail questions. Okay, how it will be. Now, in this case, as usual, you will have to define what will be your x. So, in this case, your x will be the mathematics score. Okay, and the distribution is given by the mean is 500 and the standard deviation is 100, so 100 squared. So that will be the distribution of your x of the mathematics score. Okay. Can everyone follow today's lesson? Class? Can I have your voice respond?
Okay.
Yes,
Okay.
doctor.
Okay, thank you. Now, let's move to the first question. What is the probability that the people taking the test will score below 350? Okay, so Px below 350, then it will be less than 350. Okay, so in this case, we will transform this into z. So z will be 350 minus the mean is 500 divided by the standard deviation. So that will be 100. And this will be given by, if you look at your textbook, it will be Pz greater than, less than 1.5. 350 less than 1.5. Negative 1.5. Okay. The original distribution is 500. Okay. And then you are looking for 350 less. Okay. 350. So when we talk about the standard normal, so it will be negative 1.5 less than. So this will be the area. So if you look at the table, so we will use the first table. By using the first table, definitely it will be 0.5, or if I were to use the notation first, this will be Pz greater than or equal to 0 minus Pz from 0 until 1.5. So it will be 0.5 minus 0.433, so you will get 0.0668. Okay, so that will be the probability less than 350 for the test score. What about the second one? Okay, the second one says that remedial assistance will be given to students in the bottom 10%. Okay, so when you see this kind of what we call situation, what comes to your mind would be what would be the bottom 10% means. So you will have to relate to your upper tail probabilities. So in this case, if you were to use your upper tail, where will be the location? So you are talking about this small portion of remedial assistance. Of course, remedial assistance will be given for those who are very weak or got low score, which is at this stage, not here, but here. So this area will be 0.10, 10%. For those who got here, okay, less than your Z alpha here, so they will be having what we call remedial assistance. So in terms of the actual probability, we would like to know what would be the maximum score of this particular experiment. Okay, so how are we going to solve this? Okay, so this would be somewhat compulsory question sometimes when we do give assessment to students. Okay, so PX, okay, will be given, remedial assistance will be given to student in the bottom 10%. So we are talking about X less than, okay, less than the maximum value. Okay, since the question asks about the maximum score of this group, means that what will be the maximum score that they should get in order for them to go for remedial assistance. So put it as this way. Okay, so and we know that the probability is 0.10. So this is how we form the first step in your solution. Now, of course, when we have this, we need to transform into Z. So when we transform into Z, so this becomes Z. Once we have applied the Z, it will be maximum minus the mean, that would be 500, divided by the standard deviation, 100, which if the probability value is 0.10. Now, this is somewhat like we discussed about Z alpha. Okay, what will be the Z alpha if the alpha is 0.10? So take out this portion. Okay, so max minus 500 divided by 100 is equal to, what would be your uh, so let's say, because we are talking about the upper tail, which is referring to the right. So let's say this is 0.1, alpha is 0.10. So we are looking for Z 0.10. If you look at your textbook, okay, it will be given by, okay, it will be given by 1.2816. I hope everyone can figure out that from your table. Okay, so since we are talking about this area, it will be negative value. That's why we have negative 1.2816. Now we are looking for the score, the maximum score. So solve for max. Now you will get max is equal to negative 1.2816 multiplied with 100 plus 500. So you will get 371.84. Okay, or you can approximate that into 372. Now we know that this X will be 372. That will be the maximum score that students should get for them to be in the remedial assistance group. Okay. Now, any questions before we move, class? Before we move to the exercise, which discuss on the, for the second questions, I think I mixed up my slide here. There is no exercise. Example 220. Okay. Exercise 2.8. Okay. So I choose, okay, it's correct. Sorry. Exercise 2.8. Now, why don't all of you, I give you 3 minutes. Try to note down what will be your X. Okay, what will be your X distribution looks like. Okay, before we answer the questions. For question exercise 2.8, please try on your own. You read the questions, and what will be your X and what will be your distribution of X from the given questions. Okay, looking for you. Okay, let's continue. January 3, okay, the American workers spend an average 70 hours logged onto the internet while at work. Assume the population range is 77 hours. The time are normally distributed and the standard deviation is 20 hours. What is the probability that a randomly selected worker spend fewer than 50 hours a day? Let's begin with the location of your X. Okay, so what would be your X here? Class, your X is
Hours log on to the internet while at work.
hours. Um, hours of log out on to the internet while at work. Okay, so X distributed with normal probability distribution with the mean value is 77 and the standard the variance is 20, right? Okay, so let us look at the first questions. Okay, first question will be, what is the probability that a randomly selected worker spend fewer than 50 hours? So Px less than 50. Okay, so in this case, we know the first will be the transformation. So Pz less than 50 minus 77 divided by 20 standard deviation. Okay, so you will get Pz less than what? Negative 1.35. Okay, so if you were to plot, okay, so for 0, so you are talking about negative 1.35. So negative 1.35 somewhere here, which is the same as 1.35 this area. So using the first table, you will have Pz greater than or equal to 0, which is the whole probability here, minus Pz between 0 until 1.35. So if you look at your table 1.35, 1.35, okay, 1.35 is 0.4115, okay, 0.4115. So 0.5 minus 0.4115, you will get 0.0885. Okay, so that would be the probability value. Very small probability because we are talking about the average, the commonly working number of hours used is 80. It is 80 here. Sorry, 77. Okay, 77, and we are talking about less than 50. Okay, somewhere here. Okay, very less likely. Now, what about the second question? Okay, the second question, what is the percentage of workers spend more than 1 hours? 1 hour, 100 hours, sorry. So, second question, Px, what is the percentage of workers spend more than 100 hours? More than 100. Okay, so more than 100, transform them, it becomes Pz 100 minus 77 divided by 20. So you will get Pz greater than 1.15. Okay, 1.15 positive. So let's say 1.15 somewhere over here. 1.15 greater than 1.15. Okay, somewhere here. So you will have 0.5 minus Pz is from 0 until 1.15 So this will be 0.5 minus 0.3749, which is equal to 0.121. Sorry, 1251. To answer the percentage, it will be 12.51%. Okay, 12.51%. Okay, so that will be number 2. The last one, a person is classified as a heavy user if he or she is in the upper 20% of usage. Now, 20% of above 20% means that you are referring to this. Okay, whereby the alpha is 0.20, 20%. Okay, so what would be the number of hours here? Okay, what would be the x reflecting the 0.2? Okay, now for question number 3, okay, a person is classified, so px is upper, so means that should it be greater than or less than plus? Should be greater than or less than? By right, it should be greater than lah, sebab because we want to classify them as heavy user. So greater than 0.2. So in terms of continuous probability distribution, this sign and this sign is almost similar. It does not make any difference between the two. So greater than something, some value. Yeah. So let's say the value is, say, put it as, what should I say? Heavy user. KH, I put it in SH, is equal to 0.20. Okay, transform into your standard normal. So PZ H minus 77 divided by 20 is equal to 0.20. And we know that we need to find what is here? H here. So H minus 77 divided by 20, 0.2, if you are referring to your table, 0.2 for upper tail, okay, for alpha 0.2, okay, 0.2, so this is your alpha value, that will be your Z value, so 0.8416, so 0.8416, okay, is given by 0.8416. So solve for H will be 0.8416 multiplied with 20 plus 77. So the H is actually equal to what we call 93.832. Okay, or we can say 94. Okay, or using the same exact value, so 93.8. So how many more hours did a worker have to be logged on to be considered as heavy user? 93.832 hours or 94 hours. So that would be your answer. So for an equation class, for the upper tail application of the upper tail probability distribution, before we move to the example of the, okay, any question so far? So
Not at all.
no, okay. So by now we have finished our what we call discussion on the continuous probability distribution, specifically for normal probability distribution, where we need to solve using the standard normal probability distribution. Now, before we ended our class, so we are going to solve the last part of our chapter 2, that will be the normal approximation involving binomial and Poisson. It will be very simple as what we have discussed for the Poisson approximation of binomial last time. Okay. Now, what if we have binomial distribution and we can solve them using normal probability distribution? Okay, so these are all the conditions involved where if you want to use the normal approximation of binomial probability distribution. Now, if you have what we call binomial problem, okay, sometimes it would be easier for you to solve than using the normal or standard normal probability distribution. It depends. Okay, if you have a question whereby you are required to use the approximation of certain probability distribution, then please follow the instruction. Okay, because marks will be given based on the what we call instruction given in the question. Okay, now normal approximation from binomial. We know that binomial random variable is distributed this way, and when we approximate using normal, it becomes this. Okay, how I get the mean? Okay, the mean is obtained by multiplying the number of trials with the probability of success. What about the variance? The variance would be multiplying the number of trial, probability of success, and probability of failure. So that would be the approximation that you need to use for the standard normal. Now, what are the conditions that can be used approximation of binomial using normal? Last time for a Poisson and binomial, the n is greater than 30, and somehow the other option will be is either np is less than 5 or nq is less than 5. But now for normal approximation, the three what we call criteria need to be fulfilled. The first one would be n must be greater than or equal to 30, at least 30. Okay, and then np would be greater than 5, and nq is greater than 5. Okay, so please take a look at the condition n. So everything needs to be fulfilled. So how this become possible? If you look at the original x random variable that follow binomial with only number of trial terms and probability of success 0.2, so you will have the probability distribution this way. Okay, but when you increase the number of trial, what happens? It becomes symmetric. Okay, so that is why the normal approximation is applied in this case. When you have larger number of trial, but with certain level of probability of success, you can approximate using normal. Now, when the only thing that deals with continuity correction is the approximation involving normal, because we are talking about continuous random variable, so there will be continuous what we call continuity element that need to be included in the solution. Okay, so the continuity correction factor involve if you are given equation for finding a random variable is equal to certain value of x, so you need to apply this particular what we call transformation or continuity factor, correction factor to your problem. If the question asks for less than or equal to, and you will have to add 0.5 to your x given in your question. For less than x, you will have to deduct 0.5. For greater than or equal to x, you will have to deduct 0.5. For greater than x, you will have to plus or add 0.5 to your original x given in your question. Okay, don't worry about that particular continuity correction factor. Let's look at the example. Okay, now this example can be found on page 66, example 2.21. Okay. Suppose that 5% of the population over 70 years old has disease A. A random sample of 9,600 people over 70 is taken. What is the probability that fewer than 500 of them have disease A? How likely the event will occur? So based on the textbook, okay, so X will be the number of people over 70 years old has disease A. So this will be your random variable for X following binomial. That's why we have the number of people. Now X is distributed with binomial with the number of trial 9600 and probability of success is 0.05, 5% over the four population. Now check, okay, check whether the criteria fulfill or not. The first is n is greater than 30. Okay, NP you will get 450. Okay, greater than 5. NQ is 9120. Again, greater than 5. Okay, so all the three conditions are met. So then you can answer the question. What is the probability that fewer than 500 Px less than 500? Okay, less than 500 in this case, knowing that we can approximate this into normal. So write down the approximation, the new distribution of your X following the approximation distribution element. So that would be, the mean would be NP, 480, and the variance will be NPQ. Okay. What is NPQ? NPQ will be NP is given by 480 and PQ is given by 9600 multiply with 0.05 multiply with 0.95. You will get 456. Okay, so that's why 480 with the mean and variance is 456. Okay, so that will be your variance. Now, looking at the correction factor that we need to take into account, that will be less than x. So you are going to put this way. So x less than 500 minus 0.5. This becomes px less than 499.1. Okay, so each of these steps will give you marks. Okay, now transform that, because knowing that we are dealing with normal, so we have to transform that into standard normal. So p z less than 499.5 minus the mean is 480 divided by the standard deviation, so that will be square root of 456. Okay, so you will get what? Yeah, so this will be Pz less than or equal to 0.91. Take 2 decimal point because the table used 2 decimal point. So in this case, you are talking about the area of 0.91 is positive, less than, so these are all the area. So we know that half of this is 0.5, and this one using the first concept of table standard normal. So this becomes Pz less than or equal to 0 plus Pz from 0 until 0.91. So this will be 0.5 plus 0.3186. You will get 0.8186. Okay, so this is equivalent to 82%. How likely? Since the percentage is very high chance, so the event is likely to occur. Okay, so that will be your conclusion for your questions. Now look at the exercise 2.9. Okay, exercise 2.9. Can someone tell me what is the time now? Can someone tell me what is the time now?
2:45.
What was that?
2:45.
2:45. Okay, so we should stop at 3:30, right? Okay. Exercise 2.9. Okay. If you don't have any question, I'll just proceed with the exercise. A magazine reported that 6% of American drivers read the newspaper while driving. Is it American? In your case, in your case, it's my nation. So my previous textbook is American, so in nation. Okay, now if 300 drivers are selected at random, find the probability that exactly 25 say they read the newspaper while driving and interpret the probability calculated. So in this case, what will be your X? X is the what? The number of what? The number of Malaysian drivers who read newspaper while driving. Okay, and X is distributed following binomial. Okay, how many number of trial? How many number of trial? 300, right? And what is the probability of success? 6% to 0.06. Okay, now test. Okay, it is obvious we need to test because it is under the topic of normal approximation of binomial. But when you have your questions, everything is lump sum. So you need to identify which questions should be solved using binomial, which one should be following Poisson, which one should be following the approximation of binomial to Poisson, which one should follow the normal of binomial, so on and so forth. So when you have your questions with you afterwards, you will need to identify which questions follow which distribution. So in this case, it is easy because it's under the approximation of normal. Now, check for the criteria. N equal to 300, which is obviously greater than 30. Okay. Second one, NP 300 multiplied with 0.06, you will get 18, which is greater than 5. Okay. NQ. So NQ 300 multiplied with 0.94. So you will get 16.92. Again, it is greater than 5. Okay. All the conditions for approximation are fulfilled. So we can use the approximation. So X following normal, the mean that will be 18 NP, and the variance is NQ. Okay, so NPQ is given by NQ. Is it if I'm not mistaken, this is from 300 multiplied with 0.96. 282. So typo here. 282. 282. Okay. So NPQ would be 300 multiplied with 0.06 multiplied with 0.94. So this is 16.92. Okay, so you will have 16.92 here. That will be a new distribution if the transformation to normal is applied. Now, continue with the solution. Find exactly 25. Px equal to 25 And the correction factor for equal to would be minus 0.5 and plus 0.5. So you will get P X, okay, between 25, that will be 24.5, and then that will be 25.5. Okay, so transformation to Z, so P 24.5 minus 300 divided by the standard deviation, square root of 16.92, X becomes Z. Okay, 25.5 minus, sorry, not 300. No one correct me, yeah? Not 300, it's 18. 18 divided by square root 16.92. So if you solve that, okay, this would be what? Z between 1.58 and 1.82. So if you draw 0, 1.58 over here, 1.82 over here. So you will have to deduct P Z between 0 until 1.82, the largest probability value of here, minus P Z from 0 until 1.58. Okay, so you will get 0.4656 minus 0.4429. You will get 0.0227, which is 2.27%. Okay. Now, have we answered all the questions? Interpret the probability calculated. Okay. So in this case, what can you say about the probability value? Okay. There is a 2% chance that exactly 25 drivers use or say what? Read newspaper while driving. Okay, so you can say that way. So it is less likely that this event will occur. Okay, exactly 25 will be less likely to occur. Any question, class? Any question so far for approximation of binomial to normal?
Doctor,
Yes.
for when exactly is it recommended that we check the conditions?
Okay, whenever, okay, imagine, let's say you have understood the binomial, the Poisson. That will be the basic understanding of binomial and Poisson. What you have when you deal with binomial, most of the number of trial are very small, right? Okay. If the number of trial too large means that it is greater than 30. Okay, the first thing first, you can approximate. If you are dealing with binomial, you can approximate it become Poisson. Then you have to check if the approximation using Poisson is applicable and it's okay, then you can use the Poisson approximation of binomial. And you can also use the approximation of normal. How? Just check for the condition for approximation of a normal approximation of binomial. If it is fulfilled, all the conditions are fulfilled, then we use the approximation. But how should I know? Should I use the approximation or not? when the number of trial, if you're dealing with binomial, when the number of trial is so large. Okay, larger if you have 100 trial, approximation could be to normal. If you have somewhat like a 70, 30, 35, that will be following Poisson also can. But sometimes you can also use binomial. It is not wrong if you use the two approximation. But if the question asks for you to use either one, specifically use A, then you have to use A. Don't use other than A because mark will be given for based on the instruction given to you. Okay?
Okay, thank you, Doctor.
Okay, thank you. Okay, if there is no more questions, do you want me to solve for the second question or proceed with the third approximation? Class. Solve or not solve? Hello? Do you want me to solve the second question or we proceed to the Poisson approximation?
Proceed.
Proceed, huh? Okay. Try this, yeah? So please try this on your own. Now, normal approximation of Poisson will be much more simpler because knowing that Poisson only deal with one parameter, that will be lambda. So your job when you are dealing with Poisson and you need to approximate using the normal, it will be easier compared to what we call binomial. Okay. How does the approximation look like? So if originally x is following Poisson, then if you approximate using normal, your mean is obtained by using the lambda and your variance also is using the lambda from your binomial distribution. And the only one criteria would be your lambda is big enough. How big? Is greater than or equal to 10. Some textbook, okay, some textbook says lambda can be greater than or equal to 50. It depends. Okay, but in our case, we apply if lambda is equal to or greater than 10, then you can start doing the approximation using normal. So how does this become possible? If you look at the Poisson probability distribution and how it becomes normal, so what happens is that if you have the lambda is equal to 3 and you increase the number of lambda into 10, so what you have, your probability distribution is somewhat symmetric. So when you have symmetric, then it appears to be following normal. Okay, so that will be the only condition for what we call Poisson, normal approximation of Poisson. Now, again, because we are using the approximation for continuous random variable, again, continuity correction factor is involved. Okay, the same exact continuity correction factor. If you have equal to, less than or equal to, less than, greater than or equal to, or greater than. Okay, so let us look at the example that you have in your textbook. That will be on page 67. Okay, example 2.22. Okay, your example is somewhat the sentence has somewhat been what we call rearranged, but the gist are still the same. Okay, an average of one customer per 2 minutes arrive at a checkout stand. What is the probability that more than 35 customers arrive at the stand during a particular interval of 1 hour? Okay, so in your case, it mentioned about supermarket. Supermarket checkout counter. Okay, supermarket checkout counter. Okay, now for the x, what will be your random variable defined following Poisson? The number of customer arrive per 2 minutes. Okay, the given condition is for 2 minutes. Okay, so in this case, X is following Poisson with lambda equal to 1. That is for 2 minutes. Okay, you can use Y, you can use the same X. Okay, I myself would like to use the same random variable. X is following Poisson for 1 hour. Okay, so for 60 minutes. Okay, if for 2 minutes 1, so for 60 minutes definitely it will be 30. Okay, so this will be your distribution for time interval 2 minutes and 60 minutes. Okay, now check for the condition. Lambda is equal to 30, okay, which is greater than 10. So check. You can use the approximation. How to form the new random variable you following the new distribution? So X is following normal with mean lambda, so that will be 30, and the variance is also lambda, that will be 30. Okay, so that will be your first step. Second step. Now, what is the probability more than 35 customers? So Px greater than 35 customers. Equation same, okay, more than 35. So in this case, correction factor, so Px greater than or equal to 35.5. Then do the transformation to standard normal. So Pz greater than or equal to 35.5 minus 30 divided by the standard deviation, that will be square root of 30. Okay, so you will get Pz greater than or equal to 1. Okay, so greater than or equal to 1. And then you will have, if you draw, okay, 0, 1 is somewhere over here. Let's say this is 1 greater than 1. So this is the area. So if you are using the first table, so it will be Pz greater than or equal to 0, which is half of the area, minus Pz between 0 until 1. So 0.5 minus 0.3412. You will get 0.1587. Okay, interpret the probability. So if you put this in terms of percentage, this would be, you can say 16%. Okay, to be exact, 15.87%. So in this case, you can say there is 16% chance that greater than 35, more than 35 customers arrive at the supermarket counter check within 1 hour. Okay, so write down everything according to the given equation. Okay, any questions so far before we go to the exercise?
No, doctor.
Okay, no question. Then we look at the exercise 2.10 on page 67. An average of 5 customers per hour comes to use the ATM machine. Okay, 5 hours. Okay, your textbook has been resentenced in terms of the sentences. Okay, but the same exact situation. What is the probability that more than 30 customers come to use the machine between 8 and 5 p.m.? Okay, so X in this case, since we know that we are talking average of 5 customers per hour, then we know that this is a Poisson situation or random variable. So X following Poisson, 5, this is for 60. easier say since they are using hours for 1 hour. Okay. Now, what is the probability more than 30 customers from 8 and 5? So from 8 and 5, if you count, it will involve how many hours, class? How many hours from 8 to 5?
I think 9.
9 hours, right? Correct. So if for 1 hour you have 5 customers, what about 9 hours? Then multiply by 9. So Poisson 5 multiplied with 9, you will get 45. This is for 9 hours. Okay. Now, we know that lambda is 45 and it is obviously greater than 10. Then we do the approximation. So the approximation would be x following normal with mean lambda and variance lambda. Okay, and the probability of what we are looking for, more than 30 customers, x greater than 30. Okay, correction factor for greater than plus 0.5, so p x greater than or equal to 30.1. Okay, then transformation to standard normal. So p z greater than or equal to 30.5 minus 45 divided by square root of 45. Then you will get p z greater than or equal to what? Negative 2.16. So if you draw 0 here, negative 2.16, let's say negative 2.16 greater than. Okay, so we know that we are talking about this part and this part. So it will be p z greater than or equal to 0 plus p z between 0 until 2.16. Okay, so this one is 0.5 plus this one. If you look at your table, first table, it will be 0.4846. So you will get 0.984. Okay, so that will be the probability. Most likely it will occur. So most likely 30 customers will come between 8 a.m. and 5 p.m. Okay. What is the time now, class?
3:10 minutes.
What? 3:10. Okay. Let's finish second questions before we finish the chapter 2. Now, assume that the number of asbestos particles in a square meter of dust on the surface follows a Poisson distribution with a mean of 1000. Okay, if a square meter of dust is analyzed, what is the probability that less than 950 particles are found? Interpret your answer. Okay, and we know that since it has been mentioned that it follows Poisson, so x will be what? The number of what? Number of what? The number of asbestos particles in a square meter of dust. Okay, and it follows Poisson with 1000 in. If a square meter of dust is analyzed, What is the probability less than 950? Px less than 950. Okay, so in this case, approximate into standard normal or normal. So this becomes, since your n is 1000, so sorry, lambda, which is greater than 10, so x can be approximate to normal with 1000 mean and variance 1000. Okay, and since we are using the approximation of continuous random variable from discrete random variable, then we have to apply the continuity correction factor. For less than, it will be less than or equal to minus 0.5. So Px less than or equal to 949.5. Okay, so we transform into standard normal, that 949.5 minus 1000 divided by square root of 1000. So you will get Pz less than or equal to negative 1.596. We approximate this into 1 point because we need 2 decimal point, right? So 2 decimal points, since this is 9, so it becomes 160. So if you look at your what we call table, less than negative 1.6, less than, okay, it is the same as this one. So this will be 0.5 of P z greater than or equal to 0 minus P z from 0 until 1.6. So that will be 0.5 minus 0.4452. Okay, so you will get 0.0548, which is 5.5%. Okay, 5.5% chance. Okay, interpret your answer. So you can see there is 5 or almost 6% chance that less than 950 particles are found. Okay, so that's how we interpret. Or if you wish to put it in terms of likely or unlikely, there is the event of less than 950 particles are found is unlikely to occur. Okay, due to very small probability. So class, we have finished our chapter 2. Okay, so in simple word, we can say that we have looked at how we can find the probability of our random variable if they are following binomial, or they are following Poisson, or following standard, what we call normal probability distribution, where we need to solve using the standard normal probability distribution. So having said that, we can say we can solve binomial using Poisson if the conditions are met. We can use approximation of normal for binomial if the conditions are met, plus with the continuity correction factor that need to be taken into account. The same goes to solving Poisson by using the normal approximation with the condition if lambda greater than or equal to 10, again with the correction factor that need to be applied. Okay, that would be all that need to be covered for chapter 2. Okay, so far we have what we call complete our chapter 2, and